Hello, my name is Daniel Mullany, and behind the camera is Caitlin Yates, and we are here to film a video source inspection for Sitek Process Solutions. Today, we are going to be viewing a refurbished YES 6112 Vapor Prime system. Typically, we would like to show the system from the front to start, but because of the camera and our tight spacing in this circumstance, we're going to kind of start from the side over here. This system has been refurbished and will be shipping to our customer located in Central California. So, first we're going to show sort of inside here in the electronics. As you can see, this has been cleaned up and repaired as necessary. Tubing is new. We have our isolation valve, which is new. Here we have our purge gauge. The Nupro valve back here has had the head cleaned out and reseated. Here we have our Vapor Prime flask. This will actually be filled from the front, which is a little different than some Vapor Prime ovens where you have the flask on the side. This flask is actually internal and is filled from the front via one of the programs on the system. And then all the wiring's been checked out to make sure all the connections are proper, everything's been tied up, and that this system will function properly on arrival. So that's the inside of the system. Now we're going to work our way over to the front. This system is in excellent condition. Here we have, let's just start with the buttons. We have our reset and our start button. That's pretty straightforward. The reset's going to reset the system. After you reset the system, you actually have to run a sequence in order to open the door. That's going to be sequence number 9. The sequence 9 is going to purge the system and get it back to atmosphere so you can actually open the chamber door. Here we have indicators for the items that are going to be running, whether it's vacuum, the nitrogen purge, the Vapor Prime, whether the system's been interrupted via an interlock, or whether the run is complete. And here we have indication on the primer level, whether it's full or it's low. Right now, we are correctly indicating low Vapor Prime because we do not have Vapor Prime to actually run in this circumstance. However, we're still able to demonstrate the system right now. Here we have the flask pressure gauge. This is where you're going to hook up your Vapor Prime. You'll rotate this down to the fill setting. I'm not sure if you can see it exactly, but it says fill right there versus gauge. Gauge is when we're ready to run. Fill is for when you're returning Vapor Prime into the flask. Now we're going to come down here to the bottom. Here we have a new Athena temperature controller. This is the controller that's actually going to monitor and regulate the heating elements inside the chamber. Then we have the temperature. Here's another temperature. This is not controlling though. This is just receiving the temperature from the center of the chamber. So this is your readout from the center, and this is your input for temperature control. You can use the switch here too to change the setting. You can see it's set for 150, and right now we're at 147 as the chamber's heating up to get to the set point. Here we have the vacuum gauge. This is going to let you know how much vacuum's been pulled. Right now we're sitting at atmosphere, so we're over 600. We should be about 800 right now, just in normal. And when we pump down, it's going to pull this down until we get down to millitorr as needed right here, depending on how long you actually pump down for. You'll see that this vacuum gauge will actually move throughout the cycle depending on whether or not you're purging in nitrogen or purging in Vapor Prime or bringing the system to atmosphere in general. So lastly, we have our logical sequencer. This is going to have up to 9 available programs and up to 9 available steps for what you're doing. This is all explained in the manual on how to use it. There's 9 basic functions that they pre-program or that they recommend that you pre-program in. We've already done all of those pre-programmed recipes inside the logical sequence for right now. And what we're going to focus on is number 8. Item number 8 is the typical run. The typical run we have programmed in completely normal, but the difference is that the 30-second Vapor Prime step we've reduced, 30-minute Vapor Prime step we've reduced down to 5 minutes for the purpose of this video. We're not actually processing wafers inside this chamber, so by reducing it down to 5 minutes, we're not going to sit here for 30 while it's purging something that's an empty flask. So normally you'd press start to run this system. However, because the system has a low primer indication, it has an interlock that prevents us from running it. So that's a good thing. We can't press start, it won't let us run. So what we're going to do is we're going to do sort of a manual run, quote unquote, by pressing the run button on the logical sequencer. So after we run this, we're going to go ahead and inspect the chamber on the inside. All right. So now we're getting started here. First, we're going to be pulling vacuum. So our vacuum pump is running right now, and you can actually see from the vacuum gauge right here that we're starting to pull vacuum down. There's going to be 3 different steps of the vacuum pulling down to start before we have a nitrogen valve release, and we're going to purge the system with nitrogen and then pull down again. So really you're trying to remove all the natural air out of the chamber first, then we're going to purge with nitrogen, and then we're going to pull the nitrogen out of the chamber, so that way we can pull down a vacuum and have a proper vapor prime coating condition inside of the chamber. So it's a little difficult to see just from, the room is in here, but I can see on here just fine. So we now are on the next step here. Another set of pumping down. I don't know if you noticed, but on the gauge right here, it just kind of shot back because we're going through the process of pumping down over and over again. The valves are opening and closing, and to maintain the vacuum, it's going to require a consistent pull. So let's see here, we have 1 second left. There we go. And actually, I may have misspoken right there. I noticed when I looked up that the nitrogen light was on. So that last setting was actually the nitrogen purging into the chamber. And that's why the vacuum readout was raising in terms of the pressure. It's because we were purging nitrogen in. But now we're pulling the vacuum back down again. We have 35 more seconds. So now you can see on here, since we've gone through a couple chambers of this, we're able to pull it down a lot more quickly. And specifically that last step was the purge cycle. We are purging with nitrogen prior to the vapor prime step. Okay, so now we're underneath 1 torr, we're now into millitorr, and we still have 8 more seconds left of vacuum pull. And this is all programmable for when you utilize the system. Depending on how strong your vacuum pump is and what sort of vacuum rating you're looking for, it's going to depend on how you program this sequence 8, which is all clearly described in the manual. All right, great. And so now we're continuing through the purge. As you can see, the nitrogen is back on. So the objective here is to have the chamber purged with nitrogen and then have the nitrogen pulled. Purge with nitrogen, have the nitrogen pulled. Okay, and now we have another 50-second vacuum pull right here. Again, you can see the vacuum gauge returning. You want to be careful around these systems. They will get quite hot. Touching on the chamber wall, as you can see, I can leave my hand on here. It's not absolutely dangerous, but as the longer I leave my hand on here, it gets pretty hot. And I have gloves protecting me, but with bare skin, I would assume that I could burn a little bit. And from the top, I'm feeling it. It's not too bad here, but you wouldn't want to leave any product or anything on top of the chamber. This system's going to get warm as that's what it's designed to do. Sitting here at 145 degrees C is the temperature setting. Yeah. Another thing to notice is that you'll see that the center of the chamber and the heater temperature are within about a degree right now. It doesn't have the points on here less than a degree, but they're sitting at the same degree point. So that's good. That shows us that the system is properly calibrated for the temperature setting and what it's reading. Okay, we have about 7 more seconds of this nitrogen purge cycle again before it will pull down vacuum. Okay, so now we're pulling down vacuum, but as you can see, the primer light came on. So now we're going to be moving into the vapor prime stage. Let's see here. Yep, so we have 4 minutes of this stage, 4.5 minutes. So this is the longest stage here. This is the stage that typically would be, this is the stage that would typically last about 30 minutes in total time. But because we're expediting the process here, what we programmed in was 5 minutes here. And so we have 4 minutes and 20 seconds left of this. Yeah, and another item to note is that during the N2 purge, you're going to see the temperature drop a little bit. So that's why our set point was 150, but we're down to 144. That's because you're bringing cool nitrogen into the chamber, and it will return in temperature, but every time you introduce nitrogen into the chamber, nitrogen is going to be at a lower temperature than what you're trying to hold at. It's going to drop and then return. It's going to drop and then return. So that's what this system is experiencing right now, and it's exactly what's expected. Okay, 3.5 minutes. Well, during this 3.5 minutes where this chamber is going to be sort of sitting here, rather boring, I'll take a minute to describe our company in a little bit more detail. So our company, Sitek Process Solutions, is a refurbisher of front-end semiconductor equipment. We specialize in semi-tool spin wrench dryers. It's a product line that we have 100% of spare part and service capability for, but we also refurbish a variety of other tools. Those would be vapor prime ovens, as you see behind us. They'd be mask cleaners, box washers, barrel ash and etch tools, metrology tools such as profilometers, ellipsometers, thin film measurement tools, particle counters, and a variety of others, as well as photoresist pumps, photoresist pump repairs, microscopes, and many other pieces of equipment. Our full product listing can be found on our website at www.sitekprocess.com, and you can see Sitek is spelled S-I-T-E-K. Sitek has been a refurbisher in the semiconductor industry for 20 years now, and we are located in Rockland, California. That's just north of Sacramento. All right, we have about 2.5 more minutes of priming before this cycle will be ready to enter the last steps, where we're going to purge out the chamber again and prepare to return to atmosphere. Okay, and another thing, I'll take a look right here. So taking a look at the vacuum. Our vacuum is currently at 100 millitorr, so we're at 0.1 atmospheres right now. So that's good. That shows that our chamber is holding vacuum during the priming process. So we won't be able to take a look at the back of the system during the source inspection because of our limited space. But taking a look back here, the system looks the same as the front in terms of the quality of the cleaning. We have the model number listed and original YES labeling right here. We have an exhaust port right here if you decide to hook up exhaust to the electronics area. We have the power on button. We have the relay, the breaker to power on as well to maintain power to the tool. And we have the rest of the facilities, which are the vacuum and the high pressure nitrogen, as well as the power. So it's pretty straightforward back here and pretty clean in terms of total facilities compared to other equipment that you might experience. Okay, we have about 10 seconds left before we'll be moving into the next step. And here we are. So now we're going to purge the system back with nitrogen again. And you'll see that the vacuum returned back up to, what are we at now, 100 atmosphere? Or 100 torr, I mean. Yeah, so this is going to be one of our longer nitrogen purge cycles. I just took a look on here, and we're going to be purging nitrogen in here for 3 minutes. So this is going to be a longer purge step, whereas in the beginning when we were pumping down, they were pretty short purge steps because we didn't have any vapor prime in the chamber. Now we want to be able to purge out any vapor prime that's residual in the atmosphere in order to make it safe to open the chamber once we're completed. All right, we got about 1 minute and 45 seconds left of this exciting source inspection. Okay, here we go. So now we're going to be pulling vacuum again. However, as you can see from the vacuum gauge, that we returned all the way back to atmosphere. And so the specific sequence that we're running right now, sequence 8, is going to be a system leak test. So what we're really doing is we're cycling through all the different functions of the system to perform a leak test. So as you go throughout this, you'll see that we're going to be repeating a lot of these sequences over and over again to ensure that the system is holding vacuum properly and is prepared for processing. Here we have another 1.5 minutes of a nitrogen purge. Again, as before, the temperature has been dropping a little bit because we're continually purging with nitrogen. Okay, now we're returning to vacuum step again. And I believe we have one more cycle of purge here, which will be a 1.5 minute nitrogen purge again after this. Okay, as I expected, we have one more nitrogen purge cycle here for a 1.5 minutes. She really is a beauty, huh? Okay, we're going to our last few seconds here of the nitrogen purge, and now we're going to vacuum pull again. This vacuum step, like the rest, will be 45 seconds long. Okay, back to nitrogen purge so we can return to atmosphere. Let's see here. Yep, we have a 1.5 minutes on this one. Okay, got 30 more seconds here of nitrogen purge. Okay, got 1 more minute here. Okay, down to the last couple seconds. And now that you'll see system flashing is complete. So our next step here is going to be pressing the reset button to acknowledge that this guy is complete since it's a leak test set. So we are complete, and now we should be able to open the door. And there we are. So here we have our chamber that has been refurbished and cleaned out. You can see that our temperature is slowly starting to drop now because we are exposing the chamber to the normal air that we have inside the room right here. The door seal was replaced as well, so this is a new door seal that we have. And this chamber is capable of holding 4 cassettes, so it is optimized for throughput. All right. I want to thank you for taking the time to view our exciting video source inspection today. My name is Daniel Mullany, and I filmed this source inspection for Sitek Process Solutions. If you'd like to learn more about this product or inquire about our other products, please give us a call at 916-797-9000. And to reach me directly, please dial extension 2201. Thank you so much, and have a great day.